Hi, welcome. My name is Francis Dejna. I'm going to talk to you about what's the difference between bare metal servers, VMs, containers, how to distinguish them, how to properly choose what's the what you should use or what you should consider when going with your application to the network. So we're talking bare metal, VMs, different type of hypervisors, containers. Then we'll do a quick wrap up. And if you have questions, please do so at the end. Choosing the most effective options for cloud applications is one of the key decisions you'll have to take. It's not an easy task. You need to properly consider every use cases before you go and try to put your application in productions. Here, what you'll learn, you're not going to be an expert in VMs and using bare metal servers, but you'll have enough knowledge to be able to properly ask questions around. You'll be able to navigate. In 10 minutes, you won't be an expert. I'll be doing some gross simplifications, so if you are kind of more technical, don't worry, you can talk to me after that. You can say you're wrong with that point. It'd be my pleasure to discuss with you. So, let's start with bare metal servers. What do we mean by bare metal? Generally, we're talking about a piece of hardware. You're going to run an OS. With that, you're going to have the application running directly on the OS. So, for example, if you're using Windows or Linux or any operating system you want, you'll be able to run directly your server. Think about an FTP server, an SSH, or something like that. You can run it directly on the piece of metal. I'm talking about ONAP. Not ONAP, OpenStack, Ironic, and Canonical's Mass. They are deployers that will deploy your application directly to the metal. All right. So if you need to orchestrate many applications, you'd want to consider those. Pros. Well, you don't have the noisy neighbor effect. What I mean by noisy neighbor effect is that when you have many tenants that are coming down to your hardware, you want to avoid all the miscommunication that can happen between your applications. You want to isolate them. That's for security measures. The application will be more performant also because you're running directly on the metal. You can use specific instruction sets if you know how to use them, and you can develop your application using them. The cons, well, it can get costly. If you imagine you have a bare metal server for each of your customers, it could get really expensive at the end. So you need to be considering that. It reduces agility of your customers' applications. So if you need to tie your applications to a specific servers, well, you'll have to develop it and buy that hardware that many times. Now let's talk about hypervisors type 1. What are they? They run directly on top of the hardware. So it replaces or mimics the operating system. It's more of a lightweight operating system that takes advantages and exposes resources to your VMs. Who are they? You might know Citrix Zen Servers, VMware ESX, the Hyper-V from Microsoft. Those are hypervisors type 1. It adds more flexibility than running a bare metal server. You can get greater performance. I'm going to talk about type 2 hypervisors. They are more performant because they are directly running on the hardware. You don't have that many abstraction layers to go through. And it provides good isolation between all your VMs. The cons, well, it often serves a single purpose. For example, you need to run a VM. It needs to run on ESXi. It needs to run on the Hyper-V. You are stuck with the hypervisor. right? So you lose that kind of flexibility or agility in your network. Let's go to type 2. So for type 2, we are nesting the VM into an operating system. So the hypervisor is running on top of the operating systems. The advantage of that is that you can use multiple hypervisors. VirtualBox, QEMU, Parallels for Mac, and I'm writing KVM there. KVM is a kernel modules. It acts like an hypervisor type 1, but technically it's a kernel module, so it's running on an OS and it's type 2. It provides even more flexibility, more agility into your network. You can take your VMs and build it on whatever hypervisors you want. The cons when you're adding nesting layers or nested layers, you are losing performance, right? And it asks for an OS that's already running, and then on top of that, you are going to run OSs. So you're losing memory and you're losing CPU capacities. Now for containers. Containers are running directly on top of operating systems, and they are managing all the binaries, libraries, and dependencies you need. So if you, for example, you are building an application and you containerize it, you'll actually build the image with all the dependencies, right? So it's running directly on top of your OS. That means that if you have an application that you need to instantiate X times or N times, you will use the same libraries or in the same binaries. Instantiation of containers is really fast. It's as fast as booting an application or running. The moving parts, the containers are movable at a point that if you have all the dependencies or libraries and it's managed, you can move it to that hardware. It's going to run the same way as what you are actually intended to run. The cons, well, if you have a system with many tenants, they are all using the same binaries and the same libraries, which could be a security issue. So you need to take that into consideration. Deployment of containers while maintaining proper networking is also a challenge right now. So if you need to redeploy many times, you might face some challenges there. So to wrap up, it all depends. It depends on your applications. It depends on what you want to do. For example, if you're going into stateless applications, things that are needs to be instantaneous and moved quickly, you'd want maybe containers. If you need things that are more stateful, you are building a stateful application that needs a database and that needs frequent access, you might be considering VMs. If you are not using many hypervisors, well, maybe opt for a type 1 hypervisor or a bare metal hypervisor. If you need hardware precision and manage all the bugs from your application, then go to the bare metal stage. So it really all depends on what you're going to do. Any questions about that? Yeah.
What about overcoming security issues when you have containers deployed?
Yeah. Well, you know, you can manage all the groups yourself. The security is there, but you are providing an actual surface of attack. Okay, so what you can do is or move your application to what they call unikernels, which tend to well, they are trying to be as easy to use as containers, but provide that extra security features. Or you manage the C groups yourself and you manage all the access, but then you need to be really precise on what you're doing, because you will face many problems. Yeah. Do I answer your question? Yeah. Yeah. Great. Thank you very much.